So let's take a look at this first exploration on direct variation. So I want you to take a look and see if you can describe the relationship between the weight x, so these are the weights here, and the distance d that the spring stretches from equilibrium. So equilibrium, as you notice, is this red line right here. That's the equilibrium. And then you want to explain why the distance is said to vary directly with the weight. So if you take a look at this, you notice that as the weight increases, as x increases, the distance increases. So we can say that they vary directly. Okay, so it's like a one-to-one relationship. So we can say as x increases, y also increases. Okay, so direct variation. Now let's take a look at the second example down here at inverse variation. The table shows the length in inches and the width y in inches of a rectangle. The area of each rectangle is 64 square inches. So if we say that x is 1, what would y be, right? So remember, the area of a rectangle is length times width, or base times height. So therefore, if x is 1, what does y have to be? Well, y has to be 64. So I'll pause the video, fill out this real quick, see if you can describe the relationship between x and y, and then explain why y is said to vary inversely with x. So pause the video and fill it out. So hopefully you got this all filled out. And so what I want you to notice is number one is after you filled it all in, you would have gotten 64, 32, 16, 8, 4, 2, and 1. And you notice that as x increases, our y's decrease. So what you can say as to y is said to vary inversely with x is that the quantities vary inversely when the product of the quantities is the same, right? So the answer to multiplying x and y is always the same, but the x and y will vary inversely. Okay, let's take a look at some examples on the other side. So here, classifying direct and inverse variation. So two variables, x and y, show direct variation when you have y equals a to the x, or a times x. Okay, so it shows direct variation when you see y equals a times x for non-zero constants. And then two variables, x and y, show inverse variation when they are related as follows. So when you have y equals a over x, and of course, a cannot be 0, okay? A cannot be 0, and of course, x cannot be 0 either, okay? So let's classify these equations. Tell whether x and y show direct variation, inverse variation, or neither. So what you're going to do is you just solve for y, okay, to try and figure out whether or not it is of this form, direct variation, which is y equals a times x, or whether it's inverse variation when you get this form. So let me do the first couple of examples. So we have x times y equals 5. So what we want to do is isolate the x. So if we divide by x, we have y equals 5 over x. So this looks like our inverse variation. So therefore, this is inverse variation. Inverse variation. It's hard to write with this. Okay, so the next example, letter B, we have y equals x minus 4. Now, that does not look like either of these two examples. It does not look like y equals a to the x, nor does it look like y equals a over x. So therefore, in this case, this is neither. Then letter C, we have y over 2 equals x. So we have to isolate the y. So let's multiply by 2 to both sides. So y equals 2 times x. And so that looks like our direct variation. Direct variation. So go ahead and try these next 3 examples. Pause the video. And then when you come back, I'll have the answers. Okay, so if you try these out, number 1 would be direct, number 2 would be inverse, and number 3 would be neither. Okay, let's take a look at example 2 at the bottom. So the general equation y equals a times x for direct variation, this is direct, can be rewritten as y over x equals a. So what we're doing in this case now for the next types of examples is we're going to be solving for a instead. So the set of data pairs x, y shows direct variation when the ratios y over x are constant. The general equation y equals a over x for this is inverse variation can be written as x times y equals a. So again, we're solving for a. So a set of data pairs, not pairs, data pairs, x, y, shows inverse variation when the products x times y are constant, okay? So this can be confusing because we were just looking at above where we see that direct variation is y equals a times x, right, when we're multiplying. And then, so here, when you're looking at this, it's opposite because we're solving for the a, okay? So direct is actually the ratios y over x, and inverse is the x times y. So here we want to tell whether x and y show direct, inverse, or neither. So we're going to find the products x times y and the ratios y over x to see whether these are direct, inverse, or neither. So let's take a look at the first example. So x times y, 2 times negative 12, that is negative 24. This is negative 6 times 4 is also negative 24. This is also negative 24, and this is also negative 24. If we do the ratios, negative 12 over 2, that is negative 6. The negative 6 over 4, well, that's not negative 6, right? You get negative 3/2. So we already know that these aren't going to be true. So we notice that when we have x times y, so remember x times y equals a, and then just to kind of keep it all in our head, really this is over x. So y equals a over x, right? Because we know that x times y is constant. So what we were going to say is that this is inverse, okay? So our explanation for that is that since x times y is constant and y equals a over x, this is inverse. Okay, so I'm really looking for the explanation of that. So let's try example B. Find the products x times y and the ratio is y over x. So x times y, 1 times 2 is 2, 4 times 2 is 8, 8 times 3 is 24, and we can already see that this isn't constant. Let's do the ratios. 2 over 1 is 2, 4 over 2 is 2. 8 over 3 is not 2, right? And then 16 over 4 is also not 2. So you have to be careful. Just because the first two work, you have to keep on going to check all of the ratios to make sure that it all is constant or not. So in this case, obviously this is neither because none are constant. Okay, none are constant. So this is neither. So what I want you to do is try the next two examples on the next side, and then when you return, I will have the answers for you. Okay, so looking at this examples here, you should have gotten direct variation because notice that the y to the x is constant. Okay, they're all equal to -5. So because y over x is constant and y equals a times x, this is direct variation. So when you're filling out this table, these values in here are the a values, right? Just to talk about that again. So these are what are our a values. And then remember that you're really looking at y over x equals a. So then if we solve for a again, we get y equals a times x. Okay, so that's where I am getting this value here, that y equals a times x. Okay, so then looking at example 2, we notice that x times y is constant. So because x times y is constant, and then remember again, that is we're looking at y equals a over x, or we're looking at, x times y equals a, and you divide by x to solve for the y value, you get this, which is, remember, our inverse variation. So this is a little nicer just to remember what is direct variation and what is inverse variation. Just remember those two formulas, these two. And then just remember when you are solving for whichever variable, and I'm hoping that will help you out instead of remembering both of them, because they're both very, very similar and can be confusing sometimes. Okay, so on the next video, I'll go ahead and do the next examples 3 and 4.